So we're going to go ahead and construct this confidence interval. So the first thing I need to do is put the data in the calculator. I've already done that. I named the data YAML. Yeah. And there it is. We have 30 entries. And this particular text says that if I have a sample size of 30 or more, then in my equation, I can use the standard deviation of the sample. And what equation am I talking about? I'm talking about.
You can calculate it for you.
It will calculate it for you, and I'll show you how. First, I'm going to show you why, and then I'll show you how. So, because our formula says that this is x bar plus or minus our critical value, call it z star, times our standard error, right? And so we're going to use our calculator to get this and this. We'll use our table to get this. And we know that n is 30. Right? So we'll go to our calculator. I will go ahead and come down here and hit menu, statistics, stat calculations, and we're going to go one variable stats. The list I want to use is YAML. And I hit OK. And here we go. We've got the stuff we wanted there. We've got x bar right there at the top. And then that SX is the standard deviation of our sample. So that's what we're looking for. So now we can plug that stuff into our formula. So 125.133. Whoops. So 125.133 plus or minus. Let's get our z star value from our table. So I've got my t table right here. I will scroll down to the bottom, and I will look at the z star value, or the infinite degrees of freedom. And we are constructing a confidence interval first. It's asking at what level? 75. So let's go 75 first. So you'll notice that 75 is not on your t table, which means we'll have to get this value from our z table. How are we going to do that? We're going to use the inverse. Either that, so you can either go to this, or you could go inverse norm, right? So, if I go to my z table and use that method, then what I'm going to do is try to find 75 on the inside. So 75, what's close to 75, 75, 75, 75? Looks like this one? Yeah. So that would be 0.67. So from our table, this looks like it's the closest. It's 14 away from 75. 0.75, and that one's 0.0017 away, right? So let's put that as our z star value, 0.67. Let's actually get that z star value from our calculator as well and see. We're going to get a more exact value. So for now, we said 0.67. Let's get a better value from our calculator. Someone hit menu. Probability. We'll go distributions. And we'll use the inverse normal. The area we're looking for is 0.75. And we'll leave the mean and standard deviation to 0 and 1 because we're getting a standard normal calculation. So we get 0.67. 0.74. A little better. So let's stick with that. It's more exact. 0.674. All right. Multiplied by my standard deviation that I got from my calculator, which turned out to be 47.749. $47.749 divided by the square root of 30. Now we just got to calculate this thing. And we got it. So, 0.674 times 47.749 divided by the square root of 30 is 5.876 approximately. So what is this quantity that I just calculated? It is our margin of error. So if you're asked to calculate the margin of error, it's all that stuff, right? It is your critical value times your standard deviation divided by the square root of your sample. All right? So now, in order to construct my interval at 75%, I need to add and subtract 5.876 from 125.133 minus 5.876 is 119.257. Now we're going to add. And I get 131.009. There we go. 75% confidence. Yeah. What's the next one we gotta do? It's 85%. So we're gonna use all the same stuff, except for what's gonna change with the 85%? This is gonna change, right? So this one was a 75% confidence interval. Our 80% confidence, was it 85? It was 85. It was. So now with 85%, we can just keep it. And now I'm going to show you how to do it with your calculator. Now that we've calculated the standard deviation, we know that our standard deviation of our sample, which is actually 47.749, we can actually use our calculator as well. So I'm going to show you how to do that. So I'm going to go ahead and use my scratch pad. I'm going to hit menu, statistics, confidence intervals, number 6, and we're going to do a Z interval. That's going to ask you what my input method is, and I'm going to actually have to use statistics. Okay. Sorry. I wanted to go up here. No. We're going to use statistics, okay? No. If you're going to do a T1, if you're going to use a T distribution, if you're given all the data. Unfortunately, if you put data in there, it's going to try to calculate. It gets weird. So it's just because you don't actually have the standard deviation of the population. That's what that standard deviation is. You don't feel right about doing it. So this standard deviation is, what did I say? 47.749. X bar we said was 113 point. It was 125.12. And N is 30. We're going to go with 85% confidence. And this is our margin of error. If we're going to put this, right, as a confidence interval, that's how it's going to look, right? And now we have a lot less calculator work to do. It just helps you to not have to push so many buttons if you do it like this. All right. So 12.549. So for 85, we will wind up with 125.133 plus or minus. It's not going to give us a critical value. I'm almost positive. Not going to give us a critical value. So if you really needed the critical value, you could get it from your D table or go inverse one. But for now, we'll just put 12. We'll put the margin of error at 12.5. And then we can write the confidence. 112.584. And 137.6. And there is. What do we notice if we compare this interval and this interval? No, the margin of error actually is increasing, right? So check it out. This is what happens. As your confidence level increases, your margin of error increases, right? Which makes a bigger interval, a wider interval. It's a very important concept to know, okay? As your confidence level increases, your margin of error increases, which increases the width of your interval. And that makes sense, right? If you're going to be more confident that the mean is in between two numbers, then how would you make yourself more confident? Just make the interval wider, right? And then, yeah, sure. We're going to be more confident that the mean is actually in there because, well, I have more of a margin of error. You know what I mean? So we're going to skip doing the 99% and move right along, okay? So we don't want to say this word. That's what I was saying. The confidence interval is not a probability necessarily. Okay? It's a probability, but not a probability that the mean is in the interval. Okay? What that 90% means, and I said it before, is that if I was going to take a bunch of samples of the same size, 90% of the time, if I create a confidence interval, my confidence interval will contain the true mean. So there's a picture of it. It looks like this. Right? If I have the true mean here, right, then I have intervals of these widths. 9 out of every time I'll actually contain the true mean. So this one, which one doesn't contain it? It's this one right here. So that interval wound up not containing the true mean. So now we're going to have to do a little bit of algebra. We're going to have to solve in order to find n, right? Our sample size required to get a certain margin of error. And we're going to use this formula. It's all. That is quite nice. All right. So let's go ahead and do a problem. All right, so our formula says, and actually I'm going to go ahead and derive their formula real quick. So if our margin of error is equal to our critical value, in this case some z star value, times the standard deviation of the sample or of the population, depending on what the situation is. If that's a standard deviation divided by the square root of n. I'm just going to go ahead and solve this to show you where this formula comes from. Alright, so let's go ahead and do that. And then we'll just use that formula. So, first thing I'll do is multiply both sides. That's going to make I'm going to divide both sides by z star. That's going to make those cancel. So I'll have my margin of error divided by z star equal to my standard deviation divided by the square root of n. Now I'm going to have to multiply both sides by the square root of n in order to get the square root of n to go away. Trouble looking star. Those are going to cancel. Alright, now I need to get this over here, so I'm going to have to divide both sides by it. So I'll cancel out. Square root of n is going to be my standard deviation divided by my margin of error divided by my critical value. So n is going to be, I have to square both sides, right? Standard deviation, margin of error, value, squared. And we just got to get it into that form. The way that we'll do that is just flip and flip it. So, let's just leave that. I think this the same thing as my standard deviation over 1 divided by my margin of error over z star. I'll flip and multiply. Times different value divided by margin of error. So there we go. The way that your formula has it is they're calling this standard deviation times, they're calling it z sub c. Yeah, z sub c, the critical value. It's normally called c star. So z sub c is what z star is. And they're calling your margin of error just t. But it goes by m. So there we go. Should have probably put that on the other page. Because now we have a problem. So we're going to use this formula, okay? And I'm going to write what the formula says in words. We'll make it simple. So our sample size, n, right, is equal to our standard deviation times my critical value divided by my margin of error. So now we're able to go ahead and solve this thing for a. So n equals, what is my standard deviation? It is 53 times a critical value for 95. I can go to my, 95 is going to be on my t-table. 95, I'm going to use a critical value of 1.96. Oops. 1.96 divided by what margin of error do they want? Seven frames. So we'll go ahead and calculate that thing. 3 times 1.96 divided by 7, 14.84. We're always going to round up. So we're talking about people, right? It'd be weird. You can't select 0.84 of a person, for example. So you would say you need 15. How many users? 15 users. All right. Boom. So that finishes it up. That's the first assignment.